Sweet. So general announcements, because I did not pull your slides thing up yet, and I can, but there's really not much on there. Is we have a test / mastery / whatever you want to say on whatever your next day of class is, so whether that be Wednesday or Thursday. Today, I've assigned a few things in Desmos, but what I want us to go to is marble slides, no, let's start on card sort, actually. So if we go to card sort exponentials, I'm going to pull this off so we can't see your guys' names. Give me 2 seconds to slide this stuff back up once I find it. So go to Desmos.com, log in with Google, right? You guys know how to do this. Actually, I lied. I don't think we're ready for card sort. Now, if you want to prove me wrong, sweet, but let's go ahead and do marble slides right now, because we've seen marble slides before. Just this one is a different marble slides. So in marble slides, right, just like we've seen before, when we launch the marble, it's either going to get all of our stars or not, and if it doesn't, we need to modify things. So this is going to be the beginning of our exploration on what is the form of exponential functions and what does that tell us. So for anyone playing along at home, so like Ellie or Calvin, I'm going to pause this for a minute while we work on marble slides, but when we start talking about what we noticed, I will unpause and start recording again. All right, so in looking at this slide, it started at 2 to the x minus 5, which brings up the question of like, wait, so we're talking about exponential functions, and I'm going to pause you for a second so that I take your control. So go ahead and head your notes paper. Sorry, I lied when I said I'll leave that up to you. When I said, do you need graph paper? We should always take some notes. I should have known better. I'm sorry. I already said I'm sorry. Your eyes pierce like daggers. No, that's a good thing. Like, means your eyes are like, you know, intense. Oh, by the way, the quarter that is in the frame, ignore it. I realized that if I put something shiny and detailed under there, it would stop the camera from like focus, refocus, focus, refocus, focus, refocus, like that loop that it gets stuck in. So, okay, we often talk about parent forms of functions. And the biggest thing, pencil, jar, the biggest thing that people don't understand about what makes a function exponential versus just a function that uses an exponent is what? What do we particularly care about to make the function exponential as opposed to just, hey, this uses an exponent? The what? Give me more detail. Which variable? Which is the what? Independent or dependent? Or the input or the output? The input. So to be an exponential function, the input needs to be used in the exponent. So to be exponential, the input is used in the exponent. But you guys, in slide 2, it started you with like a number to like the x minus something? Like, did it start with 2 to the x minus 5? Yeah, I think that's so. Wait, it said y equals 2. I know. To the x minus. But then you guys started changing things. Like, I was watching what you did. Some of you changed this. And some of you changed the thing in the exponent, not the x, right, but the minus 5. What did changing this minus 5 do for you? Shifted it how? It shifted left or right, right, depending on how we did it. What did changing the 2 do? Did it? I don't know. I'm asking you guys. Ooh. 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 Oh, 1 to the any power is just one. Oh, 1 would be silly to use in the base, right? So, okay, if you need to make that note, if the base is 1, this isn't really exponential anymore. It is, but it's always going to be 1, so it's really a constant function. Well, what about, like, I could do, like, 3/2. Oh, not like that, though. I can do that. So, wait, I don't think it shifts it up and down. I think the number being raised, it's the what? It's the steepness, right? All right, gonna unpause and let you guys keep going. You're welcome. We just had to write a couple. We have to learn a little bit. All right, so people watching the video, really our 3 friends at home. I'm gonna pause again, and we'll come back when we play with this again. I would say try to get to like slide 6, maybe even slide 7, before coming back to our notes, or before like hitting play again. I will tell you when you hit play again. I'll tell you what slide we've all made it to. Where's my pause button? Where's my pause button? All right, I'm not gonna pause your activity, but in case you were still stuck on slide 2. I want to show you how I process through it, and honestly, it's kind of funny if you want to watch this. So as I start playing with things, I notice that if I turn 2 into 22, I get a lot steeper, right? But before I needed to do that, I played with this number in the exponent, and I said, okay, if I make it 10, bumps over. If I make it like 15, bumps over. If I make it like 20, I keep bumping over. But the problem is when I launch the ball, it moves crazy slow, like Amar was complaining to me about. And it eventually just disappears. Like, it doesn't count. So what I realize is I'm not steep enough. Even though I can grab that first star right here, I'm not steep enough. So what if I get a little bit steeper, or a little bit steeper, or a little bit steeper? But now I'm really steep, but I'm not going to be able to, like, get the angle, right? So now I need to move back a little bit. So instead of minus 20... if I do minus 18, closer, minus 16, closer, minus 15, oh, that might be too far. What about minus 6? If I don't even care what this number is, I just made it way steeper. I could even add another 2 and make it even steeper. Too steep. Or really, I'm not close enough. So what if instead of 16, I do 15.5 to keep trying to get closer? Oh, what if I take away one of my steepnesses? Maybe I'm too steep now. What if I change this back to... there we go. I was too steep. I was making like almost like a right angle down here. So this with a bigger base to make it steeper, and a chain... oh, crap, wait. We're going to start to want to make rules. As I got more negative, right, minus 20, minus 25, I went further to the right? Interesting. Alright, keep going. Slide 4 is confusing. Well, how could you get it to move up or down? And how could you get it to also move left and right? Flip it? You don't need to flip it. Well, how do we normally flip things around? Okay, is that not working? How do we normally move a graph up and down? A constant, right? Add or subtract a constant. So try that. Katie Ann, I just tried yours and it worked. Yours. I just tried yours and it worked. Oh, I said slide 4. Are you on, like, fix it 4? Ah. Slide 6. Oh, I'm still recording. Whatever. Doesn't really matter. So, well, help me out then, somebody. How do I get this to move up? I don't think it's working. Kayla? To positive like 3. Oh, wait. Positive 3. Okay. Now, we said we want to shift left, which we said last time involved the exponent being modified. How would I shift left? Would I add or subtract up here? Well, let's play with it. If I add 2, oh, it looks like I'm shifting left. Add 3, add 4, add 5. Uh-oh. Uh-oh. How do I make the tail longer? Oh, wait, what is this? But what, okay, I get it. It's an inequality, sassy. But But so still, hold on. What is this doing? Use vocabulary. It's restricting. That is not vocabulary. Cut it out. Ha! So if we have some sort of, so now let's write down y equals 2 to the x plus 2. No. You know, no one's like making you do this. When you said no. X greater than negative 16. Now we said the plus 3 did what for us? Yeah, did it move us up or move us down though? That moved us up, right? So this moved us up. You are I'm trying to throw you guys softballs. The expression of I threw you a softball is supposed to be that softballs are easier to hit, but honestly, I don't know that they are. I mean, they're bigger, but I don't think they're easier. So wait, the plus 2, so plus 2, hold on, the plus 2 did what for us, though? Shifted left. So now we're going to be more specific. Instead of saying shift left or right, so the plus 2 shifted left. So left was the plus. Oh, we've seen this before. And we still said the 2 was the steepness. But wait, the thing that I'm being really annoying about. Yes. All right, look. I'm the one who said it. You're allowed to agree. This is what we call, anybody, last chance, what's the vocab? It's a domain restriction. Because it restricts the domain. So it says our domain is only allowed to exist when x is greater than whatever. What was her vocabulary? The line cutty off thing. If you would like to write the line cutty off thing, I think it's more words, but that's up to you. The line cutty off thing. line cutty off thing, I guess.
Yeah.
You're unpaused. You're unpaused. When it says fix it, like number 2, fix it, number 3, all I think of is fix it, Felix. I like the Ralph movies, I will admit.
Yeah, that's pretty good. Here, I've only watched like the second one. Oh, that's okay.
I think that breaks the internet. Yeah, Ralph breaks the internet. How do you what? Amar, keep doing your Desmos, please. Alright, so in number 4, Katie Ann started complaining to me, go figure, and said, I need to flip it! I need to turn it around! I think my voice was a little bit whinier, so I'm sorry. The 0.5? Didn't we say that just changes the steepness? But I didn't turn it around. Katie Ann wanted to turn it around. Oh, so we don't need to turn it around here. We just, so, wait, why did 0.5? Wait, what? Why? Hold on. Wait, that's a positive. We said negatives flipped over the x-axis. Wait, so this started at like 4, right? If I made that it flips the y-axis. Really? But wait, so hold on. Wait. 0.5, 0.6, 0.7, 0.8, 0.9? 1, oh, we said 1 doesn't work. 1.1. Wait, 1.2, 1.3, 1.4, 1.5. So wait, whether this is less than 1 or greater than 1? Yeah. Kaylin?
I think I know why it flips. Because when you multiply something less than 1 by itself, it gets less. It doesn't increase, it decreases. So as the base gets bigger, the result gets smaller. If that made any sense.
Kaylin, say again what you said.
Okay. Because when you multiply like a fraction or like a decimal by itself, it gets smaller. So as the base gets bigger, the answer is going to decrease instead of increase.
So what Kaylin just said was B, the base. When it is greater than 1, please write this down with me. When the base is greater than 1, our value is getting bigger, right? So we're increasing. When B is less than 1, we're decreasing, but why? Well, Kaylin keeps saying when something is multiplied by crap. What's the point of an exponential function? Like, why in the world, and I talked about this the other day really briefly, talking about carbon, if you remember that. We talked about carbon dating the other day. Alright, well this is why I would like you to write it down at this point. Exponential functions show, I don't know why I capitalized that S, I'm sorry, show growth or decay, and decay really just means like decrease. Show growth or decay through multiplying. But not just multiplying, multiplying multiple times. What that means is y equals b to the x is actually making one really important assumption. That if I get rid of this plus 1, zero, 1. If I get rid of this plus 2, 0, 1. If I get rid of all this jargon, oh look, 0, 1. There is always what number in front of a coefficient, or what coefficient in front of a variable? A 1. So actually, and then I promise I'll unpause, exponential functions should be y equals a times b to the x, where a is what we call the initial value when x is 0. Because guys, think about it. If b is a number, what is a number raised to the 0 power? 1. So b, so I'm going to say because b to the 0 power, no matter what number b is, b to the 0 power equals 1. So when x is 0, b gets raised to the 0 power. A number multiplied by 1 doesn't change. So whatever number is out here in front of b to the x is what the y-intercept will be until we add or subtract something out here, right? Like a constant. So I'm going to unpause, let you keep going. But that's as we learn more and more and more, right? As like, what are we figuring out? I just wanted us to realize there's actually a 1 in front of there, right? And that 1 is kind of important. So now keep, fixing it, Felix. By the way, this increasing, if you want to go back and write this on your notes, we actually call that growth, and decreasing we actually call decay, right? That's where our, so this is actually growth. What? Oh, LearnStorm? We still got 15 minutes in this class? Maybe, probably, potentially. Excuse me. So, Amar, are you paying attention to the directions that say to just change one number? No, you're okay. But you're making it harder than it needs to be. So on Fix-It 3, right, I'm actually going to pause my video so I'm not telling answers to other people. On Fix-It 3, I keep missing my pause button. Alright, because we have time at the moment while you guys are working, let's go ahead and check LearnStorm. Till the 22nd, so we will not be in school when it officially ends. If you make it to 40, you get more candy. That's it, guys?
We only have 16 assignments. Yeah.
A lot of your classmates have plenty of work to do.
Well, do your work.
Maybe you should encourage, yeah. Yeah.
Do your work.
All right, so at this point, and because the recording is going, I'm just going to make this announcement now. At this point, unless you guys ask me questions, I just want to give you the rest of the time to work and play in Desmos. And some of you guys are like getting towards the end of this activity. Like I think you might end it. There's like a free play thing on slide 24. There's a free play after like 5 challenges. So we're going to come back after fall break and pick up our learning on exponentials. Tomorrow, Thursday for you guys, we will be taking a test over our complex numbers unit, right? So like that silly like adding, subtracting, multiplying, dividing with complex numbers where you just have to change I squared into I quit. Yeah, I squared 1. No, negative 1. I squared is negative 1. That's like all you need to know. It's like all you need to know. Yes. So involving I and I ends up squared, so therefore I squared needs to turn into negative 1. So yes, are we doing the binomial, like complex number multiplications? Yes. Solving quadratics where they come out to have imaginary solutions? Yes. So that is what our mastery's on. Quadratics with imaginary solutions and working with imaginary numbers. That's it. So play with Desmos for the last like 5 minutes and we'll get out of here. I'll come around with wipes in just a second.